Hello, everybody. I'm going to go over Chapter 6, the integumentary system today, and we will discuss as a general overview the structure of the skin, all of the accessory structures, their functions, and any observations in terms of color for the skin, what goes into the repair of the skin, and what happens with aging, etc., and some of the disorders. So let's begin. Here are some key terms that you might want to refer to. So our learning objectives will involve naming and describing the layers of the skin as well as the subcutaneous layer. And then we'll look at some of the locations and functions of the accessory organs of the integument as well, and the main functions of the integumentary system. You'll summarize the information to be gained by observing the skin, and then you'll cite some steps in the repair of the skin wounds and the factors that affect its healing. So there are some main disorders that we'll look at as well. Okay. So when we look at the structure of the skin, we will name and describe the layers, and then we are going to look at the subcutaneous layer, which is under what we commonly consider to be the upper part of the skin. So the skin is composed of two parts, the skin and all of its associated structures. And we will look at all of them. The two layers are the epidermis, which is on top, and then the dermis, which is below. And if you look in your textbook, you'll see that there is a diagram, figure 6.1, which will outline that. It is entitled the cross-section of the skin. And then under the dermis, there are some supporting layer that's known as the subcutaneous layer. This is the function as well as the description of the epidermis. So the epidermis is the uppermost portion of the skin. It's primarily composed of stratified squamous epithelium. It's avascular, which means that it does not have any blood vessels that are traversing through it, and it's composed of several layers. The uppermost layer is the stratum corneum, and so it's most superficial, which means the uppermost. And then it has a special protein that is important for wear and tear, and also to prevent it from drying out, and that's keratin. So it's highly keratinized, and we'll look at certain surfaces of the skin and where it is more keratinized than others. And that particular layer, the stratum corneum, is constantly being shed and replaced. The next layer down is the stratum basale, and that's so the deepest part of the epidermis, and that produces new epithelial cells. So it has stem cells there. So the functions for the epidermis are to protect from just general wear and tear and injury and any exposure to harmful substances. It also has the melanin, which will protect us from UV radiation. Then beneath the epidermis is the dermis, and that is composed of connective tissue. And if you remember that there were two different types of connective tissue from Chapter 4, those being loose and dense. The connective tissue that we'll be looking at in the dermis is loose. And it also has, if you recall, there was areolar and then there was adipose. So that is below the dermis, a layer of adipose tissue. But this is where we have vascularization, which means blood vessels are traversing through this layer. It also has many accessory structures, such as hair follicles, sebaceous glands, sudoriferous glands, which are sweat glands, some sensory receptors, as well as other kinds of blood vessels there that are associated with the accessory structures. It functions in protection and in nourishment of the upper layer, which is the epidermis, and then it provides for skin elasticity, and it also has some receptors that are involved in sensation, like pressure and touch, that we will review. Below the epidermis, or below the dermis, is the subcutaneous layer, and that is composed, as I said previously, of loose connective tissue, and it has a lot of fat cells, which are adipose tissues. It does have blood vessels and nerve endings, which run through that subcutaneous layer. It connects the skin to the underlying muscle. It's there for insulation and for temperature regulation as well, and for sensory perception. So here is a cross section, as I was stating earlier, that you could look at in your book. But if you note the upper layer is the topmost portion, which is part of the epidermis. Here's the epidermis from here to here. This upper layer is known as the stratum corneum, and it is highly keratinized. Then this next portion in here has a layer below it, which is called the stratum basale, and this is where your stem cells are found, which will produce new layers of cells for the top portion of the epidermis. Below the epidermis is all of this area here, and that is the dermis. And if you note, there are a number of accessory structures there, and it also has some blood vessels that are running through this in the dermal layer. You have arteries and veins. We also have some sebaceous glands, and which are oil glands. We have some receptors there. There are these pressure receptors. There are also some touch receptors there as well. And then again, we do have this sweat glands. These green little things are the sweat glands. With there's pores that lead to the external portion of the skin. We do have a hair follicle, which that portion which is up above the skin is the hair shaft, and running alongside of that is your your sebaceous glands. Okay, so these are the sebaceous glands here, which are oil glands, which are very active during puberty, and these can become infected, and when they are, that produces the acne. So this is just a general overlay of a cross-section of the skin. Then underneath the dermis, we have the subcutaneous layer, which is composed of a lot of this adipose tissue. Again, there are arteries and nerves and veins that are there. But if you note, up on the top layer of the epidermis, you will not see any vascularization. There aren't any blood vessels there. Okay, and then here is a microscopic view of the skin as well. And now the upper portion of the epidermis is known as the stratum corneum. It is highly keratinized. It is a protein that allows for thickening of the of the skin and protection. One thing that I've failed to note, and I think that it's a little further down, let me go back to it. These little ridges here that you see where the stratum basale makes these humps, this is what forms your fingerprints, okay? And so they are there for grasping and holding things like on our palms of our hands, or our fingers rather, and on our toes. They are unique to each individual, the pattern, and it's hereditary. So you can look over some of these checkpoints and take the pop quiz. Okay, so now when we look at the accessory structures of the skin, we're going to look at the locations of all of those accessory structures as well as some of their functions. They are there to help to protect the skin and to give it some additional function. They include the sebaceous oil glands, the sudoriferous glands, which are sweat glands, and of course we have hair and our nails. The sebaceous glands are sac-like glands, and they are associated with a hair follicle, as I showed you in the cross-section diagram. They secrete a substance, an oil, that is called sebum. And that allows to lubricate the skin as well as the hair, and obviously if it's an oil, it's going to prevent some drying. The sweat glands, which are known as the sudoriferous glands, they are the ones that were coiled, and they are directly venting out to the surface, and they are associated with hair follicles. So they're responsible for perspiration, which cools the body. As you perspire, the perspiration is evaporating from your body and it's cooling the skin. Also, some temperature regulation involved with the skin is the blood vessels expanding. So when you get hot, if you note that your face gets red, and that's because of the increased blood flow to your skin, and it's dissipating heat. Some of the other accessory structures are hair and nails. Hair is composed of keratin, and as you saw, it develops in a follicle. And then there are different parts to that hair. It has the follicle, the shaft, which is up above the skin, the root, which is down below, and then there is a muscle that is attached to the hair, and this is called the erector pili muscle. Most often, if you see a dog where his hair gets raised on the back of his neck, this is caused by the erector pili muscle. When we get cold and our hair stands on end and we get goosebumps, that's due to the erector pili muscle being contracted. So its function for hair is to help to conserve heat, and that happens in especially where our hair is located is in areas where our skin is thinner. So on the top of our head, also in our armpit, and then in the groin area. And then our nails, they cover and protect our fingers and our toes. They as well are composed of keratin. And then they have a proximal end, which is closest to the body. That's where you would see the attachment of the nail to the cuticle, and then its structure is composed of three different parts: the root, the plate, and then the lunula. So again, it's there for protection and to help in grasping objects. So here is some of the cross sections and slides of the associated glands and hair. So when we look at the structure of the nail, we have at its most distal end the free edge, which is the very end of our nail. Then we have the nail plate in here, the lunula, which is this moon-shaped surface, and then the cuticle, which is attached back here. So if we look at the nail plate, that extends all the way out. That's commonly our nail, and that is attached to the nail bed. That is part of the dermis. And then we have the lunula, and then the cuticle, and then the actively dividing portion here of the nail, which is part of the nail root. And that's that nail root has the nail matrix where the growth is occurring. So now if we look at some of the functions of the integumentary system, it's to protect us against any kind of foreign material like bacteria. It aids in against drying out in dehydration. It regulates the body temperature, as I mentioned earlier, and it picks up some sensory information. So in terms of protecting against infection, as long as the skin is intact, you don't have any open wounds, then it's the primary barrier against any invasion of any foreign bacteria. And it has an interlocking pattern that resists any penetration. It sheds, and as it sheds, it will remove some pathogens, and it protects us against some bacterial toxins. So in and of itself, it is has an antimicrobial effect, and it protects us against some harmful chemicals that we might encounter from the environment. The skin also is there to prevent and protect us against dehydration. So the keratin is in the epidermis, and as I said, that's a protein. It's part of that stratum corneum, the top portion of the epidermis. And of course, we have some oil, which is released from those sebaceous glands or oil glands, and that's called sebum. And as I said before, another function of the integumentary system is to regulate our body temperature. So it helps in the loss of heat, and it also protects us from cold. So when we are cold, our blood vessels constrict, and when we're hot, those blood vessels will dilate. And of course, we have some evaporation of the perspiration, which has been released from the sudoriferous glands out onto the surface, and it allows for that evaporation of the sweat. The skin has, as you saw in the cross section, has a lot of nerve endings. There are some pre-nerve endings, and then there's also some touch receptors, which are higher up in the dermis, and those are called Meissner's corpuscles. Then we have some Pacinian corpuscles, which are for pressure. So when we look at this in terms of activities of the skin, we can actually put on dermal patches, which will release some medication to in through the skin. It also will allow for the excretion of water, electrolytes, and waste. And then we have as well the manufacture of vitamin D takes place with the skin, but you have to be exposed to UV radiation. So just a short period of time outside in the sunlight, we will get some vitamin D. Some of the checkpoints, and when we look at the observations of the skin, and we are most often attributing our health due to the color of the skin. So some of the things that affect the color are a pigment cell, which is called melanin, a melanocyte, which contains melanin, which is the pigmentation. Then, of course, we have hemoglobin, which is traveling around in our blood, in our red blood cells, which give us some color, some rosiness, because we get that vascularization, and or the blood is rising to the surface through the blood vessels. And when you see the pinky color or the rosy color, it's due to the fact of that hemoglobin, which is attached to the red blood cells or inside. We also have carotene, which is that can be associated with the consumption of carrots. So if we have too or orangey yellow vegetables, if we have too much exposure to that in our diet, it will cause us to have sort of an orangey color. The hemoglobin now that would cause us to have pallor, P-A-L-O-R. That would be, us looking kind of pale. That would be to the loss of some of that oxygen in our blood, and it gives us that, that looking of sort of a pale, and sometimes it can be bluish color. And then, of course, jaundice would be as a result of some of those bile pigments not being broken down through the liver. So those are just some of the factors that affect the color of our skin. Here are some discolorations. And of course, if we look, B would be that which is cyanosis, kind of has a bluing to the skin, and that's related to the lack of the hemoglobin. Jaundice here in the eyes, in the whites of the eyes, and then again in the skin because the bilirubin is not being broken down. And then here we just have a discolorization as a result of the lack of melanin that's being produced by the melanocytes. Okay. Skin, of course, can be wounded, and as a result, we need repair. And so when we look at a wound healing, this is going to occur. The wounds will heal in the areas where we have actively dividing cells. If you have a larger wound, you will have a scar, or what they call a cicatrix. And then sometimes these keloids develop, and the keloids are part of that scar tissue that occurs, and it is going to cause a sort of a rough looking area with that scar, and so it's not as flexible. Okay, and then some of the things that are going to affect the healing are, of course, an adequate, nutritious diet, the availability of blood supply to the wound, because it is going to produce and provide some of the cells that are necessary for wound healing, like fibroblasts. Other things are if we are exposed to infection, when the wound is not in a state of actively being producing a scar or wound healing, then we could be exposed to a bacterial infection. Of course, age. As we age, we don't have the vascularization that we did in that dermal layer. So in regard to wound care, we have to look at the control of any infection, and then also the application of some of those antibacterial ointments. And then with age, these are some of the changes that occur. The skin becomes thinner, so that dermal layer is not as thick. And then, of course, the tissues themselves are the loose connective tissue is such that it is not as full and thick. And then we have the loss of some pigment as a result of the lack of vascularization. Our hair becomes drier. Our sweat glands are not producing the perspiration. We don't have the circulation that we did, and there are some indications of disease as a result of changes in our fingernails and our toenails. So some of the major disorders that you might find with the integument are in terms of surface lesions themselves. So you can have what's called a macule, and the macules are those that are like, they're not raised, but they are like some spotting that you'll get. They're neither raised nor depressed. This is typical with measles. And then you have the papule, and the papules are raised, and they are oftentimes found in various stages, such as found in chickenpox and in syphilis. Some of the things that occur with a vesicle, these are fluid-filled sacs, and they are found with chickenpox and shingles as well. And then, of course, we have the pustules, which are a vesicle that's filled with pus. It has become infected. And then some of the other deeper lesions are excoriation, which is a scraping of the skin. A laceration is actually a cut. An ulcer goes down into the dermal layer, and these can be associated with bed sores. So you can have a decubitus with that, and then fissures, which are cracking of the skin. And here are some of the pictures as well, so that you can see that. Fissures with extremely dry skin, pustules, papula, etc. Pressure ulcers are skin lesions that appear where the body rests on some, the skin is resting, and there's little activity. You find these with individuals that are bedridden, and they're not very active. They are sedentary. It can go down to the dermal layer, and sometimes if it's very severe, it will penetrate down to the bone. So they are also known as decubitus ulcers or bed sores. Burns, these are categorized by the depth of the damage. The superficial the superficial part of a burn is only related with the upper portion of the skin, and then the superficial partial thickness penetrates through the epidermis and then down into the dermis. And then we have the deep partial thickness, and that deep partial thickness is associated with going down through the dermis. Then, of course, full thickness goes all the way down to the subcutaneous layer. There is a rule of 9, which is in terms of how much body surface area is involved in that burn, and if you look in your textbook, if you have like the face, it's 4.5%. If you are involved in your trunk, front and back, that's 18% each. Your arms are 4.5%. Your legs are 9% each. and then the genitalia is 1%. So they all will add up to 9%, or a 9% totality. There is another way to determine the amount of body surface area that's involved in a burn, and rather than assigning some percentages that are multiples of 9, they use the Lund-Browder method that divides the body into small areas and estimates the proportions. So infection is common oftentimes with burns, and that's because our major defense system has been compromised. So here are some burns that you can note, and the rule of 9s for body surface area. Cancer is the most, skin cancer is the most common form of cancer in the United States. We have basal cell carcinoma and squamous cell carcinoma, which are involving the upper portion of the epidermis. These are not as severe types of carcinoma, and they have a good prognosis as compared to melanoma, which is involving the melanocytes. And so those are that is going to be deeper within the skin. Here, if you note, you have basal cell carcinoma, then you have squamous cell, and then melanoma. Skin infections, there is impetigo, which is very serious in infants and newborns. It's caused by bacteria. Then we have some other skin infections that are viral in nature. Herpes simplex, you can have herpes simplex type 1, which is for the mouth. You get like a cold sore. And then you have herpes simplex type 2, which has affected the genital area. Shingles, which is the herpes zoster, and then the human papilloma virus, which is caused by or results in a wart. We also have some fungal infections. Tinea or ringworm is a type of fungus infection. So here we're looking at in these pictures, you were looking at ringworm, which is in B, and then the herpes virus, which is in A. Some of the inflammatory disorders are dermatitis. And I'm not going to go through all of these, but if you want to read on those, these are just acute, meaning that they're short-lived, eczema, etc. And then here, again, we have some eczema in B, and then it looks like a type of maybe I'm not sure what A is, but it might be a form of an allergy. Okay, inflammatory disorders that are chronic. Most of these are very, very serious. The pemphigus, it's characterized by some blistering, and it involves the mucous membranes, and it actually separates out the epidermal cells from the underlying tissues. You get a rupture of these lesions, and it leaves areas of the skin that are unprotected from infection, and you also get a loss of fluid. And most of this is found in cases of burns. Lupus erythematosus is a systemic inflammatory disorder, and it is involving a lot of organs, but you get this this area that looks on your skin and across the bridge of your nose that looks like a butterfly rash. Then you have systemic sclerosis, and there is no known cause for it, but it involves an overproduction of collagen, and it causes a thickening and tightening of the skin. Psoriasis is a chronic overgrowth of the epidermis itself, and it leads to sharply red, patchy areas, which are like an erythematosis, and sometimes it's hereditary, but it's also an immune disorder. So here, these are some chronic inflammatory diseases. So the D is psoriasis. This is the lupus with that butterfly rash. It often occurs with in women. Here you have some of that deformity, which is a skin disorder that can be related to the herpes here. Okay. Acne, we have a sebaceous gland disease, which is caused by the infectious of the sebaceous glands, which are connected to the hair follicle. One of the last disorders that I'll look at is alopecia, which is baldness, and it's associated in men with heredity and increased male sex hormones. It can be a systemic disease, and it can be alleviated through some drugs. So some accessory organs disorders here, and these are this is with the hair follicles. Okay, and that's it for the last chapter on chapter 6. And just make sure you do the objectives quiz and look over the objectives. We have one more chapter before I have the next exam to cover.